Now, from our cosine angle identity, where we had the difference of two cosine angles, from that model, we're able to develop several more. Again, the proofs of these will take up more space than I have, but you can go ahead and look in various sources to find out the proof of those so you can verify these additional identities. So what we have here are the sum and difference formulas for cosines and sines. And they're helpful to us in other applications. So imagine I have the sine of 7 pi 12ths, and I want to find its exact angle. Well, how do we do that? Well, one of these I'm going to try to do is maybe make this a sum or difference of two angles. And if so, I might be able to use one of these identities. And ideally, I want to break it up into two angles I know. So let me give you a hint, because 7 pi 12ths isn't familiar to you right off the top of your head. So I'm going to give it a hint, and we can rewrite 7 pi 12ths as pi thirds plus pi fourths. I know, you didn't see that coming, did you? But you can verify that. If I were to add pi thirds plus pi fourths, I would get 7/12ths, or 7 pi 12ths. All right, so let's say the problem starts now. I've given you both of those types of things. What can we do? Well, it looks like it's the addition of two angles using sine. So let's write that with the sine identity here. So we have the sine of pi thirds times the cosine of pi fourths plus the cosine of pi thirds times the sine of pi fourths. That's just simple using the identity and keeping straight which angle we're plugging into which trigonometric function. Now we just have to remember what were some of the exact values of some of the specific angles that we are becoming more comfortable with. So what is the sine of pi thirds? That's a root 3 over a 2. What's the cosine of pi fourths? That's a root 2 over a 2. Again, these are the exact angles of the few that we use all the time. Cosine of pi thirds. That is a 1/2. And the sine of pi fourths is a root 2 over a 2. Then from there, let's use our college algebra days. And so this becomes a root 6 over a 4 plus a root 2 over a 4. And if I want to combine them into a single fractional unit, I can do that. And that becomes root 6 plus root 2 all over a 4. And I can't reduce it any further at that particular case. So what is the exact value of the sine of 7 pi 12ths? Root 6 plus root 2 over 4. The approximational value, if I want to, is I can plug it into the black box and find out the approximation of that because root 6 and root 2 are rational radicals. The next opportunity we want to look at is looking for some exact values. And I have two different graphings up here. One represents the sine of alpha equals 12 over 13 with an angle that's measured into quadrant 2. And I went ahead and drew that graph, and you notice that the angle alpha expresses into a line that's in second quadrant. And then I labeled both my opposite and my hypotenuse. And secondly, I have the sine of beta is 3/5 with an angle that lies in quadrant 1. And likewise, I went ahead and drew that accordingly as well. So based on this information, let's ask a couple of questions. First of all, let's find the cosine of alpha. How might we do that? Well, we know that the sine of alpha helps us to begin with. So the sine of alpha equals 12 over 13, which equals, as we know, y over r. So the cosine of alpha we need to find is x over r, and x right here is unknown. So we can use our Pythagorean Theorem here that would suggest that x squared plus y squared equals my radius squared. Oops, sorry, 144. X equals plus or minus 25. Since my x is in my negative direction, I probably should choose the negative value of 25, and then that becomes x equals negative 5. From there, I now can deal with my cosine of alpha, which is x over my r, which equals a negative 5 over 13, or negative 5/13. And so there was an application of using and finding the cosine of alpha. To find the cosine of beta, as my next example using these sketches, I'm going to use the second sketch down here. And I remember again that the sine of beta was 3 over 5, which again equals my y over my r. I need to determine what my x is, and so we can do it along the same way. We know that x squared plus y squared, which in this case is 3 squared, equals 5 squared. X squared plus 9 equals 25. X squared equals 16. X equals plus or minus 4. But which one will it be, plus or the minus? Well, we notice that my angle is in the first quadrant, which makes my x value positive. So x just becomes a 4. And then from there, if we remember, cosine was my x over my r, or my adjacent over my hypotenuse. This produces a response of 4/5. Now we can start to do a little bit more things based on what we're processing and learning here. I want to find the cosine of alpha plus beta. So in order to do that, I need to go back and remember what we had for the cosine of alpha. So the cosine of alpha earlier was what, minus 5/13? And cosine of beta was, what was that? Was that 4/5? Yeah, 4/5. So that's what we discovered earlier. So with the cosine of alpha plus beta, looks like it's that top one right there. So I need to go ahead and discover what the cosine of alpha, cosine of beta, plus minus sine of alpha, sine of beta. And from here, let's just plug and play. Cosine of alpha was minus 5/13 times cosine of beta, which was 4/15. That's a 4/5, yep. Minus sine of alpha, which was 12/13, times the sine of beta, which was 3/5. All right, at least we got common denominators to work with here in a second. So that's a minus 20 all over 13 times 5, which is what, 65? Minus 12 times 3, which is a 36, all over 65. Add those together, and I get a negative 56/65. So the exact value of the cosine of alpha plus beta, based on the given information, is minus 56/65. Minus 56/65. And the last one off of this initial sketch that we have here is we want to find the sum of two angles, the sine of the sum of alpha plus beta. So again, we found all the individual things that we need to find. So the sine of alpha plus beta is represented as the sine of alpha times the cosine of beta plus the cosine of beta times the sine of beta, or sorry, the cosine of alpha times the sine of beta. Yeah, your guys are going to make those mistakes too, trust me. But good thing we caught it. Just like you guys will be able to catch it as well. So the sine of alpha, we had that earlier, 12/13. Cosine of beta, 4/5. Plus cosine of alpha. Yep, cosine of alpha is minus 5/13 times the sine of beta, which was 3/5. 12 times 4 have 48/65 minus 15/65, and it equals what, 33/65? All right, so there's the exact angle or the exact value of the sum of alpha plus beta, or the sine of alpha plus beta. in this particular sketch with these particular initial conditions.